is the oral portion of exam 1. So the paper that we were supposed to review is Convergent Evolution of Complex Cognition, Insights from the Field of Avian Cognition into the Study of Self-Awareness. It was published in 2021, and there are 5 different sections I'm going to discuss. So first off, in the introduction, it starts talking about past research and theories. So in the late 1800s, Ettinger was one of the people that proposed that avian brains evolved from parts that were composed of the striatum and not the cortex. And so because of that, he stated that birds are instinctively smart, but not cognitively complex. Then Thorpe arrived in the mid-1900s, was studying chaffinches and seeing how they learned to sing and then how they sang the songs that they learned. His study left him with the thought and the idea that birds were actually intelligent, but that at the time, the research and the science lacked enough to prove that. And then in the late 1900s, early 2000s, Dr. Pepperberg arrived or started doing research, and she found that by studying gray parrots and using model rival technique, which is a technique using a trainer, human model, and a parrot, so basically a 3-way interaction, that she could prove that birds were much more intelligent than previously thought. And so kind of her claim to fame was Alex the parrot. And so that bird ended up learning 100 labels, could request actions, and then understood same different concepts. So that was even more so than what a lot of human children could understand. And so she likened human and, mammal and avian brains to computers that were wired differently but could come to the same conclusions. So then in the next section, they talked about how research from the Avian Brain Nomenclature Consortium challenged previous ideas. Research at the time was showing that more than likely there was convergent evolution between the brains and intelligence of avians and mammalian brains. So avian brains, they understood were nuclear, and mammalian brains were layered, but they function relatively the same, just in different ways. They could come to the same conclusion, like Pepperberg said. The things like the nidopallium autolateral, the basal ganglia, brainstem pontine nuclei, and just the fact that there were lots of packed neurons in their forebrains showed that birds had intelligence, even though it looked different than how mammals did. And so things function like how they did in human brains or mammal brains, but they just might have done it differently. And so these things really started to lead scientists down or researchers down the path and showing that, hey, birds are actually really, really intelligent. And so then came along the idea that birds had complex cognition. And so based on research and some studies done, that complex cognition across animal kingdom kind of evolved independently several different times. And so they said that in order for complex cognition to exist, an animal must have a cognitive toolbox that had 4 different things. And those things were causal reasoning, behavioral flexibility, imagination, and prospection. And so most of the time, these things arose from socio-ecological challenges that were in these animals or in these species environments and surrounding habitats. And so corvids and rooks, for example, can use tools. They can make their own tools, and they can get food, and they understand how water physics work. And then you have things like scrub jays that have this mental time travel where they can think about the past, so they can remember where they put things. They can think about now, like who's watching, and they can think about the future of what they might want to eat or where something is. And so all of these things, and then parrots, obviously, they can talk and they can mimic, and then they can also make up their own sentences, like Alex. It shows that birds have a complex cognition that a lot of scientists up until recently didn't really think what was available to birds or that birds had. And so all the complex abilities kind of that these animals are showing implicate some sort of metacognitive ability. And so all these things, and like Alex the parrot was a great example, and scrub jays with how they cache food is just really fascinating and kind of shows that there is this complex cognitive thing happening in their bird brains. And so then there was discussion of how like mirror use experiments in avian species actually works. And so the mirror use experiments is taking a mirror, using a mark test by putting a mark on an animal, and if they take it off only or try to take it off only when they can see their reflection, does it show that they understand that what they're seeing is a reflection of themselves, not of another animal. And so when they did this originally, magpies and Indian crows passed, but that research is kind of controversial because many people believe that there are issues for avians when it comes to looking in mirrors, that they don't perceive it the same way as mammals. And so Pepperberg actually modified the mirror test, and she did a lot of things with like reflection by the bird having to use a reflection to complete a task instead of just identifying themselves. And so she kind of got some mixed results when she had two gray parrots, Aloe and Cairo. And so when she used them, sometimes they recognized themselves in the mirrors, it seemed, and other times they thought it was just another gray parrot. And then for scrub jays, when it came to the mirror things, and a couple other species, they cached food differently with mirrors, without mirrors, and with blurred mirrors. So it showed that some birds understood that what they were seeing was a reflection, and then other birds, it showed that they did not perceive it as themselves. They perceived the reflection as another, as competition, basically. So, in conclusion, these researchers said that the mark test is not suited for avian species, understanding their ability to learn or their intelligence. And so they said that you can use the mark test, but you also need to use multiple other tests that might show if a bird is intelligent or not. And so they stated that science now shows that birds are intelligent, but must measure cognitive abilities differently than how they have in the past. And so I think like if in the future researchers start measuring and doing different tests, that we'll find out a lot more or how intelligent birds actually are compared to what we know now. And so I'm really excited to see what the future holds when it comes to that, especially for corvids, as I find them very, very fascinating. So the second portion of this oral presentation was to review a paper on avian sleep, and the one I found was Importance of Sleep for Avian Vocal Communication. The authors were Julian Gavarro Musso, Margaret C. Stanley, and Crystal E. Kane. It was published August 17, 2022 in the Royal Society Publishing in their biology letters section. And then it basically was an overview of current research or lack thereof and theories on avian sleep and how it affects their vocal communications. So basically, they talked about that birds use vocalizations for almost everything in their lives: finding a mate, food, competition, anything you can name it. And they suspect that poor vocals may affect fitness over time. And so they also said that vocalizing is kind of difficult. Like it has a lot of moving parts. Birds both use physical parts of their body, but also mental to make and vocalize or make noises and vocalize throughout their lives. So some examples of how interference or just sleep disturbance affects birds. The first few studies were Japanese quail and zebra finches, and they showed that high artificial light affected crowing amounts and song lengths in these birds. And then another study showed kind of secondary that Australian magpies, when deprived of sleep, sang fewer songs, but they were much longer than if they had normal rest. So then it talks about closed-ended birds or vocalizers, vocal learners, and open-ended vocal learners. So closed-ended birds that learn within the first year of their lives, and then open-ended is they learn throughout their lives. They have plasticity. And so when it comes to zebra finches and barred tits, it showed that they learn songs during the day, and then songs deteriorate at night, and then they learn it again, deteriorates a little bit more. By doing this, it makes sure that they have accurate recollection of those songs before it crystallizes in their mind. And so if they don't deteriorate at night due to sleep deprivation, they might actually crystallize inaccurate songs that affect their fitness over time. So they said that no studies on sleep in open-ended learners were actually available, but adult starlings were studied to show that when they had lack of sleep, they had a harder time distinguishing similar songs than when they were had a normal amount of sleep. Um, and then when it comes to how sleep deprivation affects different kinds of vocal or vocalizers and vocal learners, innate vocalizers, which are chickens, for example, it affects them both as juveniles and as adults, and it could affect their timing, their quantity of singing, and their quality of singing. But it's likely temporary, as they get their sleep back. For close-ended vocal learners, it's kind of the same thing, but it could reduce their song repertoire, especially if the sleep deprivation happens when they're young, especially within that first 3 months to a year. And so if it continues to happen, even as they're adults, sleep deprivation, it may shorten their songs, and their songs may also come with fewer song-like elements. And then for the open-ended vocal learners, the sleep is essential for song learning, but if it continues to happen throughout their life, even though they can learn all the time, the sleep deprivation or sleep disturbance might actually reduce the number of songs in their repertoire as a whole. And so they think that that happens as a juvenile and as an adult and can actually affect their performance like the other two. And so for future directions, they were talked about research should include multiple taxa and vocal learners, not just one type of vocal learner, have closed-ended and open-ended. Birds in laboratories should probably be avoided. Let's try it on wild birds and see how they actually react. And then we should study nocturnal disturbances, not just urbanization and anthropogenic ones like during the day. And this can help us understand downstream consequences of birds not knowing their vocalizations. It might be a whole population dynamic issue. And then it can also help humans understand our own communication and sleep as a whole. I really enjoyed the paper, and I was really fascinated with how sleep affects birds. And so that is my oral presentation for exam 1.